So yeah, thanks everyone. Thanks for coming out. I know it's the afternoon on the second day, so let's keep this interactive. Let's keep everyone awake and interested. I want to make this a valuable use of all of our time. So first of all, kind of just a show of hands on a scale of 1 to 10. Look at that. Greg's already putting his hand up. So what I was going to say is if out of 10, 10 being you're kind of a subject matter expert, 1 being you're just learning at the very basics of AppSec, where does everyone feel they're at? So if you're somewhere between like a 1 and a 4, you don't have to put your hand up high. Yeah, Greg, you can keep yours up for this. Yes, you're a 1. Okay. If you consider yourself like between a 5 and a 7, okay, and who are SMEs, 8 and higher? All right, cool. All right, so okay, this is good. So I appreciate that. And just really quickly, who am I? As the intro stated, I run a practice of vulnerability management, application security, and cloud security for the Northeast at GuidePoint. My team is all practitioners. So we're doing strategy and hands-on tooling process work for companies of every industry, every size, every day. So the minority of my time are talks like this or anything with sales. The majority of my time is actually working with customers. There's some people in this room who've had the misfortune of working with me. So that's why this talk is really observations from the field. By seeing a lot of different companies between myself and my team, I see where application security trends are, and we're going to go over those, kind of where people succeed, where they struggle. So at any point, if anything is relevant to you, you have a thought, even if it's a disagreement, feel free to just throw your hand up. We're not going to wait on questions or comments. We'll just converse all the way through. So I started my career in IT, and I've transitioned to security. I worked in many different industries, higher ed, healthcare, software development, big finance. I've been here at GuidePoint for 6 years. And in these 6 years, I've seen, again, every kind of flavor of application security out there, what's worked, what hasn't. So it is the Wild West. Like as the title indicates, application security, most of our customers feel, hey, this is the Wild West. I have no idea what's going on in development. Here, this is just from the EdgeScan 2023 Vulnerability Statistics Report. So this is a mean time to resolution on application layer problems. So when we're developing applications, the flaws that we're shipping in our apps, this is the median times to resolution, the mean time, the average time to resolution for critical, high, and medium. As you see, we're about 74 days on a critical, which based on my own observations, that seems a little bit conservative. It's usually sometimes a little bit more than 74 days before a critical vulnerability in an application we develop gets remedied. The problem is weaponization of exploitation has sped up the last few years. There's some industry data that last year, between 2021 and 2022, the time to exploitation of the most critical CVEs is about 60% less time in 1 year. So weaponization, our attackers are getting faster, a lot faster, but we're lagging. This is over 2 months to fix something. Weaponization for some vulnerabilities is a matter of days. So this is the problem our businesses are facing. And then there's just the nature of development teams versus the nature of security teams. Our development teams are diverse. They're often spread throughout the organization. I have worked in higher ed for 7 years. A lot of our customers are some of the bigger universities in the country. They don't even know where all the developers are in a college. They could be in different schools doing different things. A lot of our data analytics now is using code. So we have developers all over our business, and they report to different people, and they have different workflows. They do report to different people that are usually not security people. Usually developers report up through like the CTO or something, head of product, head of engineering. But technology is becoming more application dev-centric. Our infrastructure is becoming more and more like an application. If we're using things like serverless, like Lambda, if we're using infrastructure as code. Yes, it's infrastructure at the end of the day, but what we need to secure and analyze and what we're actually making, quote unquote, is code, like an application. So between the technology becoming more app-like and requiring application security-like techniques, and just the fact that development isn't really tied to security, that causes a business problem. Is this resonating with anyone? Does this sound familiar? Cool, I see some nods, thank you. Our security teams, we partner with security teams in our customer base. Most of them lack domain knowledge on application security. Most security personnel we partner with were not developers at any point in their career. They maybe messed around programming in college or something like that, but they've never professionally developed. So it's not intuitive to security teams how to secure applications. And they usually lack visibility on development or tribal knowledge, meaning, as we established, development spread throughout the organization. I may not even know where in my organization all the developers are, where all the applications are. Oftentimes when we partner with a company, a customer, we spend weeks interviewing people to figure out all the applications, what business units are doing what are all the languages, everything like that. And then finally, in security, we like what I call assurance. We like to know an application is secure. Do you have security best practices? We don't really care about anything else in it. However, historically what this has meant, security cares about the security of an application. The developers care about an application functioning and being timely and shipping and things like that. So we were always a stop. We were always a barrier. We're trying to bolt on security to something that wasn't designed for security, and oftentimes that causes some friction and problems. So this is kind of what we're dealing with. We're dealing with that problems and exploitation and attackers are faster, but our businesses aren't any more dynamic than they were 20 years ago. We still have a lot of silos in most companies, so how can we overcome some of that? So here's some trends and how they're affecting everything we just talked about. Some organizations are trying to examine the posture of a development environment holistically. We want to know all the applications. We want to know which ones are riskier, which ones process sensitive data, those types of things. We want to know about development in general and measure it that way in security. That's a big trend. Obviously, cloud adoption in our businesses has been a massive shift. In development, it's accelerated quite a bit the last few years. A lot of our customers are using Azure DevOps. They're trying to make cloud-native applications at a much higher rate than they historically have. They're also having higher velocity. It used to be that sometimes you do a release of an application maybe once a month or something like that. Between applications based on microservices, between just the overall workflow of our developers, things are faster. We're developing quicker. And if you think about it, it makes sense. As more of our technology becomes app-like infrastructure as code, well, I have routine needs for infrastructure. I'm always going to be creating my Terraform templates and things like that. So we have a lot quicker problems. A lot of organizations want to view a logical application not just based on the vulnerabilities of the app, but also the vulnerabilities of the infrastructure that supports the app. We used to have very siloed ways of dealing with this. When we had our data centers and we had our physical servers that ran applications, one team would scan those servers and see, here's the vulnerabilities on the server. But then oftentimes we'd have pen testers or other folks, AppSec engineers, someone, actually at the application that's running on those servers, finding vulnerabilities there. And most organizations didn't marry those two. But most modern organizations say, well, if we're going to talk about how vulnerable one of our business applications is, it should be everything, not just the application, but everything it's running on. And as we get into cloud environments, this makes a lot of sense. So we cloud host this app. What's the configuration of our cloud environment to make it more or less secure, not just the application itself? And of course, trying to reconcile various best practice methods. So In development and application security, we have a lot of great frameworks, ideas, methodologies. In addition to our developers being diverse and having different apps and languages and spread out through the business, sometimes an organization has different dev groups subscribing to different best practice methodologies. So they're trying, or they have different compliance obligations. Oh, well, this handles credit card data. This is a PCI app. Whereas this, maybe we do government work and we have FedRAMP considerations or something. So trying to reconcile our obligations and our aspirations. We're trying to develop in a certain way, whether that's agile, whether we're using safe. We might have different stakeholders doing different things at the same time. Do these make sense? Is there anything else that's a current trend that is worth talking about today that I missed? Yeah. Correct. Well, that's a tremendous question. I will sort of tangentially hit on that in a later slide, but we're not going to forget about that because that's huge. And I'll take that one step further. It's not just we've abstracted the OS, so those kind of the legacy infrastructure of I have a persistent operating system that hosts an application, and there's one level of vulnerabilities and another level. When we go with serverless and we're just calling on functions, that kind of goes away but changes, and it also has higher velocity. It becomes much faster and harder to deal with, but we're also consuming platform as a service as well. So part of our infrastructure we're not running. Maybe I'm using containers as a container service to containerize my application. So we'll put a pin in that, but that's an awesome topic for this conversation. So to implement best practices in this very fragmented environment, our business from an organization perspective is fragmented, the technology is fragmented. Most of us, raise your hand if your business or organization has some self-hosted infrastructure and some cloud infrastructure. Now raise your hand if you have some persistent infrastructure and some ephemeral infrastructure. It's most everyone here. So we're fragmented in technology, we're fragmented as humans in a business. How can we implement some best practices? The first is designing things to scale. So we want to create a standard that represents a security outcome, but it's not too prescriptive. We see folks painting themselves into corners when they come up with an application security standard that's very ticky-tacky, that has very specific things. Let's anchor to security outcomes that are desired, these broader security goals that can be self-interpreted by our diverse stakeholders. Organizations that have broader standards in AppSec tend to not have issues because if I can't reconcile my workflow, my application with the standard security is giving me, I stop participating. Where if you gave me something that's not impossible but tricky, I may still keep partnering with you to figure it out. And that's what we're here to do. We want to reduce manual effort wherever possible. I think that goes without saying these days. If we could, we'd probably use AI to make this presentation. We're always trying to find ways to accelerate and automate. We want to map our business risk profile to types of application findings to focus on what matters. I kind of in passing mentioned, well, some of our applications may process sensitive or human data. They might be regulated by certain obligations. We might have part of our business in Europe, and we have GDPR, or in higher ed, we had FERPA concerns. Obviously, in healthcare, there's PHI and HIPAA. So we want to figure out what applications have what security needs. And then focus on enablement and shifting left. It's been the big buzzword for years and years. Let's shift left. Let's prevent more problems. Let's have developers using security as an outcome of what they're designing. But it's time to actually do it. A lot of organizations say we want to do it, but we aren't doing anything. The most left you can get is enablement. If I know enough to prevent a problem, as a developer or a designer, then I can avoid the entire life cycle of dealing with vulnerabilities because it wasn't created. It's the ounce of prevention is pound of cure. So these are all efforts that help support scale, support a big organization with a lot of applications. When it comes time to operationalize this system of scale, we do have to divide and conquer. So just like how we don't want to be too prescriptive, we want to be very accommodative when it's time to operationalize. And oftentimes when we partner with companies, we work on a dev group by dev group basis. Okay, here's what we're trying to do. How does this work for you or not work for you? Again, it's when a company or a leadership or a security organization just dictates, here's the new rules, this is what you're expected to follow. If I can't interpret that and make that work myself, I'm just getting off the ride. Stop the ride, I'm getting off. So by partnering with dev group by dev group for adoption, the other reason this is helpful is if I wasn't perfect when I designed my program, which as a person whose job it is to design programs, none of mine are perfect when I start. But as you start working group by group, you start to see, oh, we have to modify this part or change this part, and you didn't have it be an issue of scale where you tried to roll it out across the board and you had all these problems. Just like when we ship patches, we often ring them. You have a beta testers, so if there's a functionality issue, you got it early. Do the same thing when you're rolling out an application security program. We always like to start with the friendliest dev groups, some of the easiest ones. And if we're running into problems, we know we can course correct before we get to the trickier applications and groups. And again, we're partnering to interpret that standard. We can explain security side. We don't have to be SMEs in development or a language, but if they say, if we have stakeholders that say, I can't do this thing, would this be an appropriate mitigating control? That's us in security should be fielding that. That's what we can bring to that conversation. And then establishing true security champion programs. They say that, and I'm going to butcher this statistic, but the desired ratio of AppSec professional to developers supposed to be 1 to 10, and the last industry data I saw was that it was usually somewhere around 1 to 100. So we have about 1/10 of the staff we would like for application security. So the way we can force multiply and actually have an outsized presence in our business is security champions, having folks helping security who don't have security job titles. And this is actually something that my team's passionate about because another buzzword we've always heard is DevSecOps. And now a lot of people say DevSecCloudOps. And it's like, that's great because what it's evangelizing is the operational availability, the scalability, the security. These are all just design requirements of what we're building for our applications. But our organizations still have silos. We still have infrastructure people and cloud people and security people. And what's getting tricky is technology is not waiting for us. The technology is blending all of these competencies. Infrastructure as code is the example we keep coming back to. The technology doesn't care that you don't have blended teams and that infrastructure and security are still different in your team. So security champion programs are usually a crucial first step to actually having us all pull in the same direction, where we actually are all working on DevSecCloudOps. And then iterate. We kind of talked about it when we roll out on a group-by-group basis. Don't sacrifice good for great. If you have a thoughtful program or standard or something you're working on, a lot of our customers get analysis paralysis. And really the value we're bringing them is, here's something we're going to try. It's that nice push. We can always iterate. We iterate on our applications. Our applications aren't perfect on V1, so why would our application security program be perfect V1? As long as it's pretty good, we can make it great over time. And then again, scale up the efforts. A lot of times when we talk about ephemeral workflows, we're talking about things like gating. So now we're kind of getting back to the question of, if you have this non-traditional infrastructure supporting our applications, you actually have a whole different paradigm for how you're going to secure that. It's not a matter of I have an operating system I secure and an application I secure. It's all one blended technology resource that has to be secured in function and form right out of the gate. And we don't have a lot of time to do it because with a lot of modern applications, everything's ephemeral. They're constantly scaling, being torn down, spun up. So the only thing we can do is prevent problems, one, or two, detect and control drift. So I have a sanctioned process where we're not going to allow something very insecure to get created because I won't have time to find its problems and fix them. I have to prevent them. So I come up with a system that is preventative, that basically stops very insecure workloads, but I also have to make sure everything's going through that good process. It does me no good if outside of that secure process, other things are being spun up. But again, we all raised our hands and said, hey, we have some persistent technology in our companies and some temporary technology. Our programs have to have multiple modes. They have to understand and accept and function with, well, for some of my apps, I'm trying to stop problems, and that's my only choice. And some of my apps, I can go back and fix problems. When you're doing that, the stopping of problems, gating, those types of things, you have to start with auditing only. You have to see what would I be breaking, right? Just like with a lot of our detection controls, even in endpoint security. Oh, I have a new policy. Let me do it in audit-only mode to see who I would break. What would I break? We have to do the same thing in AppSec. We have to focus on the highest impact applications. We have established our business risk profile. We know which apps are the most critical for us. Well, we want to make sure we understand the posture and we have either compensating controls or these better security methods. It matters more on our high impact applications. And then focus on the most severe issues and expand. Usually we say, well, we'll start with the criticals. Now that's a whole other conversation, why that paradigm doesn't always track these days. But the most severe issues, again, just like the most important apps, are where we should focus. And then create cadences for program review, maintenance, and maturation. So many folks, even if they go through a really thoughtful exercise and try to accomplish all these bullets, they look at it as a one-time transformation. But we do need to iterate on a yearly or semi-annual basis. Does our program still fit our business? Did we acquire a new subsidiary, and now we have to establish standards to accommodate them? Or technology changes on a year-by-year basis. We're using new technologies. A great example of this from the other half of our practice, vulnerability management. At lunch, we were talking about SaaS platforms. And we have great ways to find insecure configurations and maybe inappropriate data use in our SaaS platforms like OneDrive or Salesforce or whatever. But a lot of businesses simply don't have a program responsible for that, because vulnerability management was always host and networking gear centric, and application security was always application centric. Well, now that we're consuming platform as a service or software as a service, if our program doesn't have a concept of that and what the expectations are and how we deal with that, those technology changes leave us insecure just because we did all the right thing 2 years ago and everything has changed. Our business has changed, technology's changed. So do these make sense? Any kind of thoughts or questions on any of this? Did we speak to your point enough? Okay, I'll take that. Sure, yeah, please.
I'm also finding that we're getting much better at software development. Like, there are many teams out there that are incredibly, really good software development. I think that's the second part of, like, we're seeing a big evolution, right? While things are still sort of old and legacy, there's also really exciting part that people are doing a lot much better software in terms of usability and security, which I think is exciting.
I would totally agree. There's one where I think we're getting much better is avoiding what I call flaws. So in an application, you could have a vulnerability or you could have a flaw. To me, a flaw is a self-imposed vulnerability. So in the actual custom code I've created, I did something insecure. This is typically something we would find with static analysis, interactive analysis. Those are the types of things I really do see your average development org being more mature, and we see a lot less just poor coding practices. But part of that is because our organizations have a better mind for it. Technology has been better at finding those problems. But part of it is because a lot of times we're deferring our coding to third-party code. So there's less that I have to make, so of course there's going to be less problems I introduce, in addition to just being a little bit better and having better technology. As I mentioned earlier, our programs need to accommodate our mixed and diverse technology environments. An application security program has to have a good mind for flaws that we create versus vulnerabilities in our applications we didn't create. And so we talked about gating here. We start with audit only. We want to prevent these problems. If we're having applications that are mostly third-party code, which a lot of our customer applications really are, the 80% of the code base is libraries, third-party code, open source, they'll pass a gate because oftentimes a vulnerability in those libraries has not been found and disclosed yet. So when I shipped my app to production, it passed with flying colors. But then a week later, it was vulnerable because we leverage a library that a vulnerability just came out on. I mean, log4shell was this, like to the max. So there's also that element of we are getting better about not making problems, but we're deferring a lot to third party, and sometimes we're good about that, and sometimes we're not. So I think that's a really awesome point. Any other thoughts here? Yeah, of course. No. A program here? So it depends on the organization. Some organizations that are larger actually have an AppSec team. Some organizations make this, there's a blended team that does vulnerability management and application security. Some organizations, like smaller financial organizations, so in finance they like risk. They like security being a function of risk. So sometimes offshoots of risk will do this. Like a large financial institution would probably have an AppSec team. But a smaller one might have some person that's got a risk title that might have to do this. But so how I'm answering your question is, who would design this? Who would define these standards? But we all implement it together. We are partnering with our developers. We're getting security champions that maybe aren't security people at all. We all have to chip in to actually make this work. Sure, that's an awesome question. It's not silly at all. And then reviewing it, right? Reviewing it isn't just internally. If I design this thing, I have a very specific perspective on it. I think it's awesome. But is it working for all my stakeholders, for all these other people? When I review it, I want to review it 360. So that's why not only do we all have to implement it, we all have to make sure it's staying current. So to examine posture holistically, this is a screenshot of an application security posture management tool. And it's just to give you an example of some of the technologies that organizations are adopting to try to get high-level stats. Now, this is a screenshot of our lab, so the data is terrible because it's not real data. But I should have had Matt make better data for us. Have his students do it.
Do you have something against this particular company?
Oh, I'm not even going to cite the company because we're in the adult room here, so we don't have to pitch anything. I only have our logo because I didn't want to make a new template. I have nothing against the company. I have something against my lab. I didn't put enough data in this. So sorry, this is a me problem. But normally, if you used a technology like this, you'd have even better numbers. You'd have more compelling narrative. So I was just kind of making excuses for my poor data. But no, I have no problem with this vendor, or really any of the vendors, because this is a really great capability that vendors are trying to give us, where, again, we established at the beginning, security folks often never worked in development. So this isn't intuitive to us. But there are tools that'll tell us, well, what's our mean time to resolution? On the first slide, we saw the average for criticals, highs, and mediums. Here's that data for us. Discovered versus closed. How are we trending? What are our top risks? in this particular terrible data I've done, though this actually is some of the more normal data, like realistic, I mean, the top 2 critical risks, we have almost 500 instances of open source vulnerabilities. This is very normal for a company. I can look at that little widget and I know, even without being intimately aware of how our developers work, well, we have a lot of vulnerabilities in third-party code. So again, it's not to pitch for particular vendors or technologies other than these are ways that we see organizations starting to get a high-level view of what's out there, what's our general posture. And if you think about it, we could filter these statistics to certain applications. So if we knew all the applications that process credit card data, we could filter the stats just to that and measure that as a key risk indicator. So, and these are just generalized problems. We have hard-coded secrets. We have user passwords and source code. Those are hygiene issues that tell us, hey, these are things that we can prevent with enablement. We can do training for our stakeholder developers because those are preventable problems. Looking across repository by repository, we can see who's working on what. And again, this high-level information. Well, this repository has APIs that it's hosting. So that's potentially data exposure. This repository actually has sensitive data. So knowing those basic things are ways we can start to partner instead of, again, just wagging reports in people's faces. We can answer operational questions with some of this technology on who's working on what. How impactful is it to the business? If we understood the criticality of a repository, we could label it here and report accordingly. That's what this business impact is for. What's our attack surface? Here, we know we have APIs in these applications. That's something we should be thinking about. We know that some of these are user-facing or internet-facing. As we have cloud-native applications, these technologies are getting good at correlating the configuration of our cloud with the posture of the application. So we know, hey, here's a flaw or a vulnerability in an application, and it's accessible to the world. Technology can tell us that today. So here's some observations from the field. Organizations are typically consolidating on fewer vendors for application security products. They just want to make things simpler. A lot of those application security vendors are offering a portfolio of offerings now, too. In the old days, maybe I only made a dynamic testing tool, so I had to buy a dynamic from one company, a static from another. Now, a lot of organizations have many different offerings, and so customers are going with that for business reasons and just, simplicity. Customers are really eager to realize the CNAPP experience. So Cloud Native Application Protection Platform is what CNAPP stands for. And this concept was designed by Gartner a few years ago to talk about cloud-native applications and the security platforms and security capabilities that should protect them. And their vision is everything from testing the application in development all the way through the security of the cloud subscription, all the way through runtime protection on use of that application should all be one platform called a CNAPP, which is great and it's sensible and it's convenient. The problem is no actual vendor had all of those capabilities working well in one package. They've been racing the last 2 years to try to develop all those capabilities. So we see a lot of organizations, they've read the manifesto on CNAPP. They say, yep, we like that. And we have a lot of cloud-native apps. Let's get a CNAPP and just kill all the birds with one stone. And then they get into the real world and they say, hey, these things can't do everything. And usually these CNAPP vendors, where they're currently still needing to build capabilities, is on application testing. They're usually very good at testing or measuring the security of your cloud configuration. They might even have some great workload protection, some runtime things, but actually doing static analysis, doing really thoughtful software composition analysis and telling you the vulnerabilities in your third-party and open source code and things about how exploitable and actually relevant those findings are, those are the places they still have room to grow. So if you're in an organization that has a CNAPP or is looking at CNAPP, just be realistic in what you're trying to do with it. It's really good at cloud security. It needs to improve to be good at application security. Does that make sense? Any kind of thoughts there? Might be. Okay. More operational tool sets offer security features for better or worse. Because it's easy to figure out third-party libraries and check if they're vulnerable, a lot of tools are telling us, hey, your application is using a vulnerable library, but it doesn't really know if it's using it. The difference between a very capable software composition tool and just an operational tool that's looking at library security is reachability, exploitability. How relevant is this? And also things like, yeah, just upgrade it to the latest. Does that have new vulnerabilities? Will that break something? A good SCA not only will tell you the vulnerabilities in third-party code, but if it's relevant, and do some regression testing to see, will I be taking a step backwards or sideways even if I fix this? Organizations are struggling with staffing the right AppSec resources. I run a team of people that we hire out because organizations say we don't have enough AppSec people. So we kind of come in and try to keep things going because maybe they have job openings they can't fill, or they just don't have enough budget, or things like that, which is why we want to automate. That's why we want to scale. We want to force multiply, because most of us are facing not having enough AppSec people. I don't have enough AppSec people. And then what's a huge focus for our customers is API security, because we know that everything's an API. Some modern web apps are just, the UI is really just a series of API transactions. So if we can secure the API, we can secure most of that app, is the thought process a lot of our customers have. And some are turning away from DAST, from dynamic application testing, to favor API security because they say, well, really, the dynamic testing I need is making sure my APIs can't be misused. Does that make sense, or any thoughts there? Cool. So what are the kinds of problems we're hearing about? This is similar to the kinds of aspirations folks have. Organizations will say, we're pretty good about some remediation, but still have a lot of vulnerabilities. And that's where, when we showed screenshots of a tool that kind of categorized types of problems, you can start to develop through lines of, our organization is very good at not writing problems. Our static results are fairly minimal, but we have a lot of third-party vulnerabilities. So that's something we can focus on and augment. So just even wrapping themes around the data is how we can start to drive progress. And then also, many outstanding vulnerabilities. A lot of organizations try to implement a new AppSec or vulnerability management program around their technical debt. They say, I have thousands or millions of vulnerabilities. I'm making a program to fix this. It's like, well, you're making a program to prevent you from doing that again. So there's two components to these. One, I've coined a very unpopular phrase, but I'll use it. It's, you have to stop the bleeding before you clean up the blood. And that's, we got to this place because our program wasn't preventative enough. So there's two parallel efforts. One is not perpetuating that cycle, and the other is driving down just the technical debt we have. Oftentimes, folks say we have a ton of findings, it's hard to action on them. We kind of talked about that just a second ago. If you can wrap themes or through lines, what is the nature of these problems? What is their root cause? Let's address that and then go fix these. And that usually, in application security, has a lot to do with often basic posture. In the screenshots we saw, we had problems with hard-coded secrets. Again, we can do seminars, we can have training labs. There's even training technology that we can target developers with to help drive towards that problem. Or maybe it's more effective and responsible use of third-party code. By having higher level understanding of the problems in our environment, we can have higher level solutions, so we're not just constantly playing whack-a-mole with vulnerabilities. And the other thing too is, a lot of people, even on pen tests, on application pen tests or environmental network pen tests, they look at the report and they go, oh, look at these 10 things the pen tester did. Let's make sure we get those sorted. The real value of that report is, well, is there some larger reason they were able to do this thing? Is there some more holistic fix we can have rather than just, okay, on this system they did XYZ thing. Well, what other systems could I do that on? This happens in applications all the time. Let's look at our application pen test results and look for themes. Look for morals to the story. Oftentimes, we talked about how we have diverse development groups. They often run different assessment tools, and that data is siloed and fragmented. So the screenshots that I had on the previous slide are a technology that ingests all your findings. You can have 5 different developer groups using 5 different static testing tools, and you could aggregate all of that in an ASPM technology. So that's a handy way to still accommodate. We talked about how we want a standard that has an outcome, a goal, but isn't too prescriptive. One of the tangible ways where we aren't too prescriptive is saying you have to do static analysis with a quality SaaS tool. We don't care what that is, and we'll just ingest your findings. That's usually a great way to partner and collaborate and scale and compromise. But it leads to poor visibility and silos of data, which again, an application security posture management tool can help alleviate. Oftentimes, folks struggle to find the responsible party for remediation of findings. So we found problems with applications. This happens a lot in pen tests, but whose is this? So this is not a fun one. This is a roll up your sleeves. We've had customers literally make task squads to go through their CMDB, make sure all applications rolled up to the appropriate parties. That was their only job. Sometimes we've had people take on contractors on a 1-year, 2-year term, and they just sneaker net it, almost, kind of thing. So, and this is usually where no platform will help us. I have a whole other talk about what platforms help with and what they don't, and this is the big one, is no technologies today. Few technologies today will actually tell us who should be responsible for what, right? They might tell us an active user, they might tell us a code contributor, but if we really want to get mileage out of our AppSec program, we need to do the not fun, hard, roll up your sleeves work of getting our metadata in order. And then we don't have enough people. And this is where, well, how can we scale? How can we focus on our most critical and regulated applications? If we don't want to forget about anything, but if we had to forget about something, we know we're focused on the right things. So that's one way organizations like ours, we can help fill in some of those gaps, but this is a very common feedback and from everyone. Anything else, kind of any other, I don't want to say pain points, but anything else is a problem or just something that's working against your application security outcomes? Pardon? Oh, yeah. Yep. So, yeah, I mean, the data is siloed, but sometimes that's for a political reason, right? It's like, no, this is my tool. Only I could do this. Or the other one that's interesting that happens a lot is we find a problem. We even know the responsible party. We go to that risk or business owner. Hey, here's this problem, this application. You're using end-of-life third-party code. Well, that's fine, but this is a critical app, and there's nothing we can do about it. That can't be upgraded. Just like in systems management, when you have that end-of-life OS or the end-of-life third-party software, you go to the business owner and go, oh, we have to. This is like, we can't stop the business. We have to use this thing. Sometimes that becomes political as well, because then security says, I don't believe you. And then it becomes this whole contentious thing, and when that happens enough, you start to get a lack of participation on this governance at all. Yep. Yep. So that's a hugely important point. A couple thoughts on that. It is actually rare that an organization that we sit down with has all their applications labeled by criticality. We always say work back, like someone has to know this business, work back from that. So when I rolled out an application security program for, it was a subsidiary of a major US bank, we had that exact problem. They said, well, we don't know which versions of our app or which criticalities or even the servers that support them. And I said, but someone here on our compliance team knows our obligations for compliance to the bank and to the industry. So we started doing meetings with the compliance people who weren't even technical, but we would interview them and we would take that information and use that to find the related technology, the related application. We did it that way. Sometimes folks go to their IT departments and say, do you have an uptime rating on these things? And a lot of folks are better about having like a DR rating than an actual like criticality rating. Criticality to them is like and a business continuity team might have this, maybe not IT. So work back from the data you have, and then sometimes you have to make sweeping assumptions. Sometimes we just say like, hey, anything that supports a database, we're going to assume is critical. And then when we're going to treat it that way, and the business will very quickly tell us which ones aren't. Like, hey, I shouldn't have an SLA this quick on this. That's a nothing. It's like, that's fine. At least we made progress. So I think that's a tremendous point. But on an earlier slide, we said, don't sacrifice good for great. That's the place everyone sacrifices good for great. It's like, no, let's get some. Even if 50% of the environment has an accurate rating, that's better than 0. So we have 2 minutes left here. Any other kind of questions or thoughts? Yes?
Challenges, governance, and decentralization.
Mm-hmm.
You can put the standards out, provide the tools, but then when you leave the dev teams up to building the pipeline, configuring them, how do you know they're doing it to the standard? Like, how do you enforce them to do it the right way? They might come up with different ways, and then the script happens.
Yeah.
It's something we're trying to wrap our heads around.
So application security kind of rhymes with cloud security. And in a lot of our businesses, people went out and got cloud on a P card and a prayer. They bought AWS, right? And then we had to come in later and find it all and secure it all. And we're doing this with development. Whether it's actual applications or infrastructure as code or whatever, anyone with an endpoint, in theory, could develop something, unless they're super, super locked down. So we need some more carrot than stick. We want to have a secure and a thoughtful process, and we want to encourage people into it because it's going to be very hard to lock down every possible way people could develop around us. But also, if we've gotten that participation and they've come through the channel where we have visibility, this technology, these ASPM tools, one thing they do is they have policy compliance overlays. So not just for policy frameworks like ISO or FedRAMP or things like that, but also you can make custom policies. And you can also be alerted of shadow development. Because if you integrate at the SCM, I can see where people are starting to stray. They're not using my pipeline. Or they've configured the pipeline incorrectly. So by convincing people to come in to a place where I have visibility and I can wrap a posture management platform, I can at least start to define those issues. Mm-hmm. Well, your champions can rat on people. They can tell you where stuff is outside your visibility vector. Never discredit a good rat. Any other points before we break? Yeah.
Outsourced and offshore development, where the communication requirements is really often through an intermediary.
Yeah, so that's tough too because oftentimes, just like outsourced IT, you might have your contract with those folks may give them some right to do a development a certain way. So we always like at renewal time to try to get some of our standard outcomes into that relationship agreement so that we can point to that and say, hey, you don't have to use this exact thing, but you have to be doing these things as part of our deal. But when you're mid-cycle, before you've done that, that's very tricky, and that's, again, where it's mostly a soft problem. We have to partner with them and try to entice them to give us the visibility to do this. Or we've had some orgs say, our outsourced development, you now have to develop we'll give you VDIs for development, so we control the infrastructure you're developing on at least, to at least have some level of understanding and control before that next renewal with those partners, and they can infuse the agreement with something that's more in line with what we want to do. because that's a huge point. Awesome. Well, thank you, everyone. Really appreciate it.